Hey guys, good morning. Welcome to the Fundamentals of Aerospace Engineering lecture series. Today we are going to see the topic on functions of piston engine. This is Professor Nehru, Department of Aerospace Engineering, SLS College of Technology. Last classes we have seen the aircraft power plant introduction. Today we are going to see the piston engine in detail. So in introduction, piston engine or reciprocating engine are commonly used in the small aircraft. Their primary function is to convert the chemical energy of the fuel into the mechanical energy, which is then used to propel the aircraft. Here are the key functions and the components of a engine in an aircraft. The functions of the piston engine in aircraft is air fuel mixture intake, compressor. In air fuel mixture intake, the engine intakes and mixture of an air and fuel. This mixture is critical for combustion process that generates powers. Components, carburetor or fuel injector systems are the components involved in this fuel air mixture. Compression function, the piston engine compression air fuel mixture in a cylinder. Compression increases the mixture's pressure and temperature, making it more volatile and ready for the combustion. Components involved in this compression is piston and the cylinder. The next part is combustion. Compressed air fuel mixture is ignited by a spark plug. This combustion process generates a rapid expansion of gases that push the piston downward and creating mechanical energy. Components involve spark plug, piston and cylinders. Power stroke. The force from the expanding gases pushes the piston down, turning the crankshaft in the. This is the primary power generating phase of the engine cycle. Component involves piston, connecting rod and crankshaft. An exhaust state function. After the power stroke, the exhaust valve opens, allowing the burned gas to escape from the cylinder and be expelled out of the engine. The components are exhaust valve and exhaust manifold. Next, the crankshaft rotation. The linear motion of the piston is converted into the rotation motion by the crankshaft. This rotation motion is used to drive the propeller. The components are crankshaft and the connecting rod. And the propeller driver is crankshaft rotation motion is transferred to the propeller and generating thrust to propel the aircraft forward. Here the crankshaft and propeller are used. Next, cylinder houses the piston and is a site for the intake, compression, combustion and the exhaust process. Pistons moves up and down within the cylinder to compress the air fuel mixture and the transfer energy to the crankshaft. Crankshaft converts the piston linear motion into the rotor motion to the propeller. Key components: cylinder, piston, crankshaft, connecting rod, spark plug, valves, carburetor, fuel injection system, cooling system, lubrication system. Crankshaft, power piston, cylinder that we know. Connecting rod connects the piston and the crankshaft. Spark plug ignites the fuel air mixture in the cylinder. Valves control the intake of air fuel mixture and the exhaust of the combustion gases. Carburetor mixes air and fuel in the correct ratio for combustion. Cooling system keeps the engine at the optimal operation temperature to prevent overheating. Lubrication system reduces the friction between the moving parts and the prolongs engine life. Coming to the four-stroke engine, the engine cycle is a type of internal combustion engine that completes a power cycle over four-stroke of the piston during two crank revolution. It is the most common type of engine found in the cars, motorcycles, and many other vehicles. Four strokes are intake, compression, power, and exhaust. Here, detailed explains of each stroke. Intake piston movement is both piston move downwards from the top dead center to the bottom dead center. Valve action: intake valve opens and exhaust valve remains closed during this stroke. Air fuel mixture, as per piston design, it creates a vacuum that drawn air fuel mixture in a gasoline engine. Just air into the cylinder from the intake manifold. Compression stroke, piston move upward from the bottom dead center to the top dead center. Both the intake and exhaust valves are closed. The air-fuel mixture is compressed and increase the pressure and temperature is prepared for the combustion. The third one is power stroke. Piston move, the piston force downward to top dead center to the bottom dead center. Both valves remain closed. In gasoline engine, the spark plug ignited the compressor air-fuel mixture. In diesel engine, the air compressor such as high pressure that fuel injected into the cylinder ignites spontaneously due to the heat of combustion. Expansion, combustion of the mixture product high pressure, high temperature gases that pushes the piston downwards, generating mechanical work. Final stroke, exhaust stroke. The piston move up and down from bottom dead center to the top dead center. Valve action, exhaust valve open and the intake valve remain closed. Upward movement of the piston forces that burn the gas out of the cylinder throughout the exhaust valve and into the exhaust system. Coming to the two-stroke engine cycle, two-stroke engine cycle is a type of internal combustion engine operates at complete a power cycle with two strokes of the piston during only one crankshaft revolution. This is an consist of the four-stroke engine which required four strokes of piston to complete cycle. Here, detailed overview of the two-stroke engine cycles. Here, two strokes, one is compression stroke and power stroke. Two-stroke engine cylinder consists of two main strokes, power compression strokes and the power stroke. Each stroke encompasses the multiple events that would be separated into the four-stroke engine. Compressor stroke intake, as piston moved upward from the bottom dead center to the top dead center, the fuel air mixture is drawn into the crankcase or cylinder throughout the intake port. Compression, the upward movement of the piston compresses the fuel air mixture into the combustion chamber. The second power stroke ignites and combustion takes place. Near the top of the stroke, the compressor fuel air mixture is ignited by the spark plug. Expansion, the combustion of this fuel air mixture produces a high pressure gas that pushes the piston downwards and creating mechanical work. Exhaust, as per the piston near the bottom of the stroke, the exhaust port open, allowing the burned gas to escape from the cylinder. Simultaneously, fresh air fuel mixture entering the cylinder from the intake port and transferring port, helping to expel the exhaust gas in the process for known as scavenging. Thank you.